All right, so hi guys. Again, I'm Zong Han, and today I'll be doing like a little sharing on how one might be doing, how one might want to go about building your real-time chat application using Flutter, and with Firebase specifically as our backend. So I've personally developed like a couple of production commercial apps using Flutter, and I've absolutely been floored by how easy it is to build very beautiful and performant apps due to the framework. And this is essentially why I'm here today, like very excited to share the Flutter gospel with you guys. So why are we actually setting real-time chat apps as the context of this sharing? Because I feel that like real-time chat apps, right, they pretty much demonstrate almost the entire range of features that modern apps nowadays typically has. And if you're just starting to get your hands dirty with Flutter, I hope that the services, the packages, and the widgets that I'm about to share will actually help you guys out. So besides Flutter, why Firebase, right? So Firebase is essentially like a development platform owned by Google, which provides an entire spectrum of services and tools for modern app development. And the thing about these services is that they're actually very well integrated with Flutter, because Google has actually provided very intuitive and ready-to-use packages for most aspects of Firebase's services. And in fact, Google has invested so much thought and effort, right, into these plugins that there's even a like fancy collective name for them called Flutterfire. And essentially, Flutterfire makes full stack development on Flutter super easy. So these are the touch points that we'll be covering today. And we'll kick things off, the crux of a chat application, implementing like a chat stream and interacting with it. So to make this like live stream of messages happen, right, we're going to be using Firestore. And what Firestore is essentially Firebase's flagship NoSQL document database. And we're going to be using it to store our messages and to integrate this database into our app. You will need to install the Cloud Firestore Dart package. And moving on, the first Dart concept that we will touch on when it comes to working with like real-time data is that of streams. So streams are sort of like asynchronous iterables in the sense that instead of getting the next event when you ask for it, like promises or futures, the stream actually tells you when there's an event, when it's ready, right? And on Flutter, it's extremely easy to create such a stream, especially using the Firestore package, as you can see. So in very little lines of code, right, we have now actually created a stream that provides an array of like the 20 latest message documents from a specific conversation thread with the ID group chat ID. And now that we've created a stream, right, what can we actually do with this stream? Well, stream builders, right, are widgets on Flutter that you will come to use a lot and love when you're actually working with real-time data. And all you have to do, right, is to actually attach this stream to a stream builder. And whenever there are changes to the snapshots, right, the document snapshots, the stream builder will actually rebuild itself with the latest data automatically by itself. And this is actually key, right, to building a super reactive UI that actually reflects changes in data in real time, which is perfect for our application. So if we look at the code over here, right, it's actually very straightforward. Once you attach the message stream to the stream builder will try to connect to your database. And in the meantime, right, snapshot.has data will be null. So while it's fetching the new documents, there will be a loading spinner. And once it actually fetches, when has data actually is no longer null, then you can process the data and render them accordingly. So this is like a short, the video that I have over here is like a short demo per se. So the list of messages is basically the stream builder rendering like a list of an array of messages. And basically when I click send, right, I'm running a transaction to the database. So it's like separate. But as the database gets updated, right, you can see that the list view gets updated in real time as well, which is pretty cool. Like you can see in very little lines of code, we actually implemented like an actual live stream. And I briefly mentioned about transactions. And one thing that I really love in working with Firestore and on Flutter is the idea of like how easy it is to really write atomic operations that are dependent on the current values of the document. So atomic transactions, right, are basically transactions whereby all operations, right, within the transaction occurs either successfully, all of them successfully, or the entire transaction will fail. And this is exceptionally useful, right, if you want to update a document based on its current value, right? In other words, in the case of concurrent edit, like when you create a transaction and your transaction is reading documents and another client somewhere, right, tries to modify any of the documents that you have read, right, within the transaction, Cloud Firestore will actually retry the transaction with the latest data. And this actually ensures that transactions, right, are run on up-to-date and consistent data, which is super, super useful. Because if you're running like an event or ticketing app, then you wouldn't want like people to oversubscribe, right, to your events, something like that. All right. So this is an example of how run transactions can be written. So in this case, right, as you can see on the screen, right, this run transaction, I initiate a transaction. And within this transaction function, right, I actually fetch a document from the database, and then I process this data, right? I try to figure out what should be the latest newly updated data that this document should have before I update it. So in the event that while running this transaction, right, someone else tries to access the same document and edit the same document between the get and the update, right, this entire run transaction function will actually be void and rerun itself again, right? So it's very intuitive in a sense, very easy to implement this. And another thing that blew my mind, right, when working with Firestore is the thing that it's very easy. Firestore actually comes with offline persistent support. So what this means, right, is that when you are online, right, and you fetch data from Firestore, right, Firebase actually caches a copy of the data that you're using, so that even if you get disconnected, right, or your app goes offline, right, you can still access the data and manipulate it. And why I say manipulate, right, is literally manipulate, right? You can write, read, listen to, and query the cache data. So when your device, so even if you're offline, you can actually run transactions. And when your device actually comes online later on, right, Cloud Firestore actually synchronize any local changes made by your app to the Cloud Firestore backend. And I have sort of like an example over here. So as you can see, this device isn't currently connected to the internet, right? But I'm like editing a message. So you see, ha 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 mukata is an edited message. So on the right, is when I actually activate, on my Wi-Fi, and then I enter the app again. And then you see, ha 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 mukata is updated. Wow! So it's like mind-blowing, the fact that you don't really need to write your own stuff. So so moving on, we have push notifications, which is also very, very important when you're writing your own chat application. So to make push notifications happen for our Flutter chat application, right, we'll be using two core Firebase services. The first one being Firebase Cloud Functions, and the second one being Firebase Messaging. So what Firebase Cloud Functions are, essentially, is that Firebase Cloud Functions, right, is a serverless tool that lets you automatically run backend code in response to events that are triggered by Firebase features and HTTPS requests. So for example, you can write your own script and upload it to Google's cloud environment, which runs upon creation of like a message document in order to carry out the logic to send out a push notification to a device. So using Cloud Functions, right, you can imagine how easy it is to actually build a serverless architecture around your Flutter application. And recently, there's actually been tutorials online, right, which teach you how to use Dart to write your Cloud Functions. So what this means, right, is that in a way, today, you can actually write a full stack application, front end and back end, using just the Dart programming language, which is quite sick, right? So aside from the Firebase Cloud Functions, right, we also have to use the Firebase Messaging package for Flutter. And this package is pretty simple. What it provides, right, is basically just some boilerplate code, or provide some boilerplate code for you to enable and handle notifications. So I'll just quickly run through the code snippets. So it's pretty straightforward, just some boilerplate code to get your app started. But I guess what might be your point of interest is this on resume and on launch. So basically, you notice that there's a message thing being passed in, right? So this enables your app to be able to dynamically respond to different kind of notifications based on the kind of like payload you get from that notification. So if you like receive a notification from a certain person, you can open a chat with that person's data inside. So yeah, it's very intuitive as always. And of course, you have to first get the token, get the push token from the peer device. Then you can push it to the device. So this is again some very intuitive API that it provides. Okay, so this is like an example of a cloud function written in JavaScript. So what this basically does, right, is I'll just quickly run through. Because you can see, right, what this cloud function does is on creation of like a message document, right? I process the data, I determine what kind of payload I want to send out, and then I just send out the payload to the device with that push token, the relevant push token. So yeah, it's pretty straightforward. Okay, so now we move on to security, which is also very important when building a chat app, because you don't really want anyone and everyone to be able to just like read and edit anyone's message documents, right? Because privacy is key. So one thing that you might be, one thing that's interesting is, one thing you might be thinking about is, it seems that throughout our entire app, right, we can just be writing transactions to our Firestore database without any form of authentication, right? We are doing transactions directly from the client. So where is that layer of security, right? And the thing is, Firebase was actually built with serverless architecture in mind. So they actually have that covered for us. And the secret sauce, right, is actually Firebase Authentication. And what Firebase Authentication is, right, is basically Firebase's authentication services that allows users to log into your Flutter app using things like mobile phones, email, Facebook, Google, etc., right? And the thing is, when you actually log in the user, right, using Firebase Authentication, right, when you make any request to Firestore through the Firestore package, right, all your requests to the Firestore database, right, is already authenticated in a sense. So yeah, so some things that I forgot to mention is that aside from security, right, the Firebase Authentication is very useful because when you register a user, right, you already have like the particulars already ready with very few lines of code. So if you are signing up through mobile, then obviously your Firebase user will automatically have their mobile number, or if you're logging in through Google, then you'll have their email as well. Then another cool part, right, is this idea of caching the user. So if you come from a web development background, right, usually when you receive like a web authentication token from your server, if you're using web, for example, you might probably like save that token in like your local storage or something, and do some logic, right, such that this token will persist even if you refresh the browser, etc., etc. But the thing about using Firebase Authentication, right, is that even if you queue your app, right, and then you open it up again, when you create an instance of Firebase Authentication, and then you call the method current user, even if you previously queued your app, right, you can still fetch the user again, right, and basically determine whether or not user is logged in. So this really abstracts away a lot of like the boilerplate code that typically we write in order to manage like persistent authentication in a sense. And yeah, so aside from that, of course, we're talking about security. So again, when you're making requests to Firestore, right, requests are actually already tagged to the user for authentication. So what do I mean, right? When you create like a Firestore database, right, you actually have to write some security rules, and these security rules will govern what kind of users have access and what kind of write or read access to what kind of documents. So the part which might be of interest is this part, basically the message part. So if you're already logged into Firebase Authentication and you make a request, right, actually this request.auth.uid is already provided within that request, and you can cross-check it with whether or not the message, right, was sent by either him or sent to him. And if it's true, then you can read it, right? And if you are the creator of that message, then obviously you can delete it or edit the message, right? Yeah. And then of course, if you are not the user, then you cannot like create messages on his behalf, So it's very intuitive to write this kind of like write access or read access on using Firebase security rules. Yeah. So I would like to stress the importance of writing these rules if you happen to want to use Firestore, because recently there's a bit of a hoo-ha about how a lot of developers, right, when they use Firebase, right, or use Firestore, they don't really write the rules properly. So in theory, right, as long as you have like the API endpoints, you can just anyhow read like anything and just destroy the entire database. So be sure to write your security rules properly. So aside from security rules, because it's a chat app, right, so since it's a chat application, naturally we'll be paranoid, right? What if people actually get our Firebase login credentials, right? So maybe you can use AES encryption, which is what I usually do when I have to implement like a chat feature. So using the AES encryption standard, right, everything that you upload to Firestore will be encrypted, and then you basically fetch the encrypted messages, and then using some global security key from elsewhere, maybe a microservice, then you can decrypt it on the client side. So personally, I use the encrypt package to do it, and then as you can see, it's very easy to just write some helper functions or some lines of code to decrypt and encrypt messages, Yeah. Just one thing to note, there are two things when you want to use like AES encryption. The first thing is that you have a super secret key, which only you and the peer should have access to. So if you want to do like client to client encryption, right, then you don't store that super secret key anywhere, right? Once you share that key, you destroy it. And the hacker anyone who tries to access the database should never have access to this. But then on the other hand, there's this thing called initialization factor. So this initialization factor, right, is dynamically created every time you try to run a transaction. So you have to send this IV key to Firestore as well. So in other words, right, just take note that in theory, right, the attacker will have access to your IV and the encrypted content. But as long as he doesn't have your super duper secret key, all is good, right? The IV basically creates some kind of like randomization to make it very difficult to crack your encryption, even if they manage to like decrypt one message, right? Because of the IV key that's randomized with every transaction, with every single document, right? You cannot crack the rest of the messages. So IV keys are important, but they can be shared. Okay, moving on, your user presence. So user presence, what I mean by that is, storing like whether or not the user is online or offline. So in order to make this happen, right, we will be using Firebase real-time database. So one thing you might be wondering is, okay, why use Firebase real-time database instead of Firestore? So one thing to note, right, when you're using Firestore is that we are actually charged based on usage. We're actually charged per write, per read, per delete. So for something like user presence, right, when the peer or your user, right, whenever they minimize the app, it counts like an offline. When they maximize the app again, when you open the app again, it is an online, right? So basically, if you use Firestore, there's going to be a lot of writes if the user just goes offline, online, offline, online. So we wouldn't want to do that, right? Because money is limited. So you can use real-time database where we are charged based on bandwidth. And the thing about the Firebase real-time database is that the how you stream and how you write data is very similar to Firestore. The syntax is very similar. So very little friction between going between the two. All right, so another thing that you might want to use is this mixin that Flutter provides called Windows Binding Observer. So like I mentioned, when you minimize the app, right, you have to create some way for the app to know whether or not the user has minimized or maximized it or opened up the app. So this Windows Binding Observer listens to that status, and whenever something changes, right, as you can see in this code snippet over here, right, you can update the Firebase database value right, based on whether or not you have opened the app or paused the app. And yeah, so personally how I do it is I create like a empty widget. So this widget returns like a sizeboard, which is like invisible widget and I just plug this widget in like in a column on any screen that basically where I want to listen to the status of the user yeah. And so this is like an example, quick example of it being in action. So user presence, right? So yeah. So as I open the app, close the app, open the app, close the app, right? On the other end, my peer who is listening to my user status will get reflected accordingly. So that's pretty cool. It's real time. So just a disclaimer, right? Actually, the Firebase real-time database actually provides a status or a node, right, where data is actually stored by the user being online or offline. However, there's a lag time before a user actually disconnects after minimizing the app, because the disconnect is not immediate, right? Once you minimize the app, right, it actually takes a while for it to be officially disconnected. So typically, if you use this, right, there's going to be some lag time before your user status gets reflected. And that is the reason why I manually change the values using the widget Windows Binding Observer. Yeah. So one thing you take note of. Okay, so now since we have a little bit of time left, I'll just like to share a bonus section, display pictures, right? So why I say it's bonus is because it's not exactly tied into Flutter or the Firebase storage package per se, but it is a very useful tool to consider since when you're building a social network of sorts, because display pictures So what I mean, right, is that typically you want to like zoom in on when you upload a photo and you want to have like a thumbnail, you want to zoom in on the face. So traditionally, it's very hard to do that without using any external services, because the face can be anywhere on the image. So basically what I do is what I discovered is actually it's very easy to connect Cloudinary, right, to a third-party storage solution. So it can be Google Storage or it can be like S3 or whatever. But once you hook them out, right, by creating some very simple documents in your storage, right, is that when it's hooked up, you can actually create a very simple helper function, right, where you put like Cloudinary prefix the Cloudinary URL, right, and then you just attach a query encoded Google Storage public URL, and then what is returned is actually a URL that generates like the kind of image that you want. So for example, what I sometimes do is like crop face thumbnail, so you can see it's very nicely cropped right. The face is the image, the photo is like a rectangle, but it actually cropped out a circular image with the face as the center, just like that, right? Super, high tech. And the thing about Cloudinary is that it provides some fun tools like pixelation as well, right? So so basically Cloudinary also provides some image manipulation tools such as pixelation. So they just pixelate just the face, which is pretty high tech but with so little effort. Okay, so this is something that you might want to consider when you're using Firebase storage or S3 and you want to do some image manipulation. You can write some helper functions using the Cloudinary API, which is quite cool. So I guess that's the end of my presentation. Hope this is of help to you guys. If you have any questions, then just comment. Then I'll just reply.
All right. So there's one question from the viewers, right?
Yeah.
So is this app in production?
Oh, okay. So this particular app that I showed you, right, is some of a client app that I'm working on now. So we're going to push this out this week. But that said, because I mentioned I previously ran a edtech startup. So for that startup, we actually had to implement some live chat functionality as well, where we connect students together and solve math problems lah. So for that feature, we also implemented a live chat using the same technologies mentioned here. So if you're concerned about scalability, I guess one thing that I read out on was that Firebase scales horizontally in a sense. So even as the traction of your app increases, right, your volume increases, the speed of the queries and the writes will still be constant speed. Like it won't affect, there won't be any lag time. If that's what you're concerned about, like scalability. So I guess what I'm trying to say is that it's a very production ready solution. Yeah.
Right. Yeah. So I mean, shout out to Firebase.
Yeah.
All right. So next question I would say from David Tran is that if the app got success, how easy is it to migrate or integrate with other services? So have you, like, for example, used AWS with Firebase or?
Okay, so for previously before I used cloud storage, right, I didn't use AWS, but I used Cloudinary for my for image storage prior to Google Cloud Storage. So I guess these kind of services actually provide some API endpoints for you to call, right? So you basically just need to upload the image to that endpoint, and then you just upload normally. So I guess even though I haven't really used native Cloudinary plugins or native AWS plugins for Flutter, I guess it should be quite easy to write your own in a sense. You get what I mean? Like API, like just submit a file to an API endpoint.
So I guess it's just like more towards piecing all the pieces together.
Correct.
So for myself, I think also that I didn't use a lot of these kind of services, but more or less Firebase and other services or API services is just piecing it together.
Yeah.
So I have another question from Johnson. Yup. And this is, I guess, because of your experience as a CTO in a startup or a tech lead. What skills and knowledge would you recommend to be equipped with being a tech lead?
Okay, so some context. I guess, okay, so personally, right, I started developing apps 3 years ago. So I did like web dev for about 2 years. Then it was in October 2018 2019, sorry. This is 2020. So last year, October, when my startup wanted to build a native client, then I picked up Flutter to build the app. So in a sense, what I'm trying to say is that I think I'm very noob at building applications. But because of modern technology at Flutter, right, you can get the entire setup running very fast. So skills and knowledge wise, I guess
adaptability.
Just learn whatever you need to do. Yeah, when you have like a requirement that comes out of nowhere, then you just go and adapt and learn accordingly. Yeah. But I guess the transition is nowadays to become a tech lead is quite easy, in a sense. Yeah.
So I guess in summary, would you say like being adaptable and really just diving into the what do you call that, the framework and tech? So no fear, and just being adaptable.
Yeah.
All right. I think you've already gone through, but maybe you can refresh some people's memory. How do you optimize Firebase cost? Cost be cheap.
Yeah. Yeah. So okay. So I did consider this a few times. So one thing is user presence, right? So user presence, how I solved that was using Firebase real-time database right? Instead of using Firestore, things that consist of like a lot of writes. You want to use a separate service. Another thing is perhaps like, okay, so personally, right, if I'm not dealing with real-time data, if I'm not dealing with data, it needs to be streamed in real time, right? I use MongoDB for all of my other like database needs. So that takes away a lot of cost as well. Another thing is in the context again of a chat application, if you are doing things like editing messages, reading messages, right? So once you fetch a message, right, then you want to mark it as read. So it cannot be like every time I send out a message, right, I mark it's originally unread. Then once I receive, then I write again. I do another write to make it read. So in a way, when you send out one message, right, it's basically going to be 2 writes, right? So it's times 2. So how I personally solved that was basically I have another Firebase value called current chat that the user is in. So basically, when the user is currently in the same chat as you, right, you can listen to that Firebase value, right? I didn't use a string builder for that. I use like a listener, which is very easy to attach in Flutter, right? And if the user is already in the chat, then you just like minimize the number of writes by marking it as read, since the user probably is going to see it, he's in the chat right now. So that greatly reduces the number of writes required for me. Yeah, so I guess it really depends on the context as well. Just be mindful that you want to minimize the number of writes, I feel. Yeah.
Yeah, so having, I guess like Firebase is free for a certain amount of reads and writes,
Yeah.
right? If I'm not wrong, per month, right?
Yeah.
So a chat app is a lot of
yeah,
writes.
definitely.
So yeah, keep in mind on that. And thank you for the suggestion. Just a very simple, I guess, is it like a Boolean or?
Yeah, like, string, like what's the
string.
chat ID the user is in.
Right. So a simple chat ID
yeah.
update. Right.
Yeah.
Okay, that's cool.